C. So as I've mentioned previously, ukuthi y is equal to C. So this is AB, it is the area that gave us area above point in question, of which also shape 3. So we're gonna take C of shape 3. So it will be 476.471. All over IXX, same 132.534 times 10 to the power 9 times B. So we're at B. So this will be the whole distance. So B will be 500. And then punch all those values in your calculator to get your answer. So if you punch our calculators, we get 0.090 newtons per millimeter squared. And then we move on to shape C. Move on to point C, So again, our shear will be the same. So it's 50 times 10 to the power 3 times, again, since we are at C, so we can see which is still at C. The area above point in question, it is the area of shape 3. So it will be 500 times 500 times 476.471 all over IXX 132.534 times 10 to the power 9 times UB. So since this is our point in question C, so C does not longer cover this whole distance, but C only covers this distance. So this will be our B. So our B, of which is 100. So again, you punch those answers in your calculator to get the shear stress at C. So when you punch those values in your calculator, you will get 0.449 newtons per square millimeter. And then you move on to calculate the shear stress at D. So at D, we can see that the shear stress at D, it is at the neutral axis. So you must note that so shear stress, it is the neutral axis. So shear stress at the neutral axis is at maximum. So once you calculate, or when you're calculating shear stress at D, in your neutral axis, you'll have maximum shear stress. So again, it would be 50 times 10 to the power 3 times the area above point of contact, because you are still at the neutral axis. So when we're at D, we can see we have this area above point in question, and we have also this area above point in question. So when calculating area above point D, it will be this area plus this area. So it will be 500 times 500 times its y dash bar, of which is 476.471, plus the area of this shape. So area of this shape will be 100 times e height. So here we have y up. So here we have y upper. So y upper is from the neutral axis where we are at to point A. So this is the height we need. So y upper will minus AB, of which is 500. So it will be y upper 726.471 minus 500. 726.471 minus 500, of which will be 226.471 times 8 y dash bar. So again, y dash bar is the distance from the neutral axis to a center of the shape that gave you area above point of contact. So we are already at the neutral axis, so we'll just simply divide this height by 2 to get y dash bar. So times by 113.236. This all over IXX 01 over IXX 0132.534 times 10 to the power 9 times OP. So we are at D, so D is in the neutral axis, so this distance will be our B. So our B is 100. So you punch these values in your calculator to get shear stress at the neutral axis. So it's 50 to the power 3 times 500 times 500, 476.471 plus 100 times 226.471 times 113.236, 32.54 to the power 9. So the answer I'm getting, it's 0.459 newtons per square millimeter. So you must remember, when calculating shear stress at your neutral axis, that shear stress will be the maximum shear stress. So when continuing calculating other shear stress at other points, if that shear stress at those points is greater than the one at the neutral axis, that means there's a mistake you've made in your calculations. So we have calculated shear stress at A, we've calculated shear stress at B, shear stress at C, shear stress at D. So we're left to E and F. So shear stress at E is equal to same S, of which is shear, of which will be 15 times 10 to the power 3 times area. So as I've previously mentioned, that area, it is the area above or below point of contact. So we've mentioned once you pass your neutral axis, you're no longer looking at the area above point in question, but you look at the area below point in question. So E is our point in question. So the area below E, it is the area of shape 1, of which will be 500 times 400 times y dash bar. Same thing, y dash bar will be distance from neutral axis to the center of the shape that gave you area below point of contact. So it will be y lower minus y bar. So y lower, it's 772.529 minus y bar of shape 2. So y bar of shape 1, we got it to be 200. So y dash bar will be 572.529 all over IXX, which is 132.534 times 10 to the power 9 times UB. So we're calculating shear stress at E. So this whole distance will be our B, of which is 500. And then you get your answer. So the answer I'm getting is 0.086 newtons millimeters squared. So we can see that the answer that we are getting is less than the shear stress at a neutral axis, of which we could mean we are in the right direction. And then calculate shear stress at F. So shear stress at F will be equal to 0. newtons millimeters squared, because when you are at F, there's no area below point of contact, so area below point of contact. So in your equation, once you have 0, automatically your answer will be 0. So we have calculated shear stresses at point A, B, C, D, E, and F. So we must be able to draw a shear stress distribution diagram. So it will be shear stress So you draw your shear stress distribution diagram. So you draw your structure here. So you have A, B, C, have D, E, F. So you simply do, you project lines from your points. And then you draw a line here. So this will be your 0 line. So, and then you simply plot all those shear stresses that you calculated. So shear stress at A, we got it to be 0. And then shear stress at B, we got it to be 0.09. And then we calculated shear stress at C, we got it to be 0.449. And then we got shear stress at D, of which is the neutral axis, of which is 0.459. We also got shear stress. At E, of which was 0.086. We also got shear stress at F to be 0. Once you've plotted all your points in your diagram, you simply join those points. So it will be this point, join this point, join this point, join this point, and join that point. So this is how you draw your shear stress distribution diagram. So guys, this is how you deal with shear stress. When they say calculate shear stress at any point in question, you simply follow those steps whereby you calculate y lower, y upper, and then you calculate ixx. After you've calculated those steps, then you can calculate shear stress at any point in questions. I hope this, guys, makes sense to you. So yeah, so this is the basic of shear stress. On the next session or the next video, I will do a little bit more complicated example so that you guys be prepared for your test on Monday.